No. Okay, so you also need to know what three things need to be true in order for a function to be continuous. If I were to draw, I'll go back over it in a second.
What's in the middle of f and c?
If I had a graph and it had a hole in it, like right there, it had a hole in it, and then but it was defined over here, like I guess it should be. But it had a solid dot up here. Well, sorry, it has a lag in it right now. Okay, so if the dot was here, hole was here, well, technically, f of c is defined because there would be a dot there. So f of c is defined, and the limit exists because the limit from the left, and the limit from the right are the same thing. So technically the limit exists and c is defined, but they're not the same thing. They don't equal the same thing. So this function would not be continuous because f of c is different from the limit of f of c. So all three things have to be the same. The limit, this function has to be defined, so there really can't be a hole there. If there's a hole at all, then the function's not continuous. The limit has to exist, so there couldn't be an asymptote or anything like that. And all three of them have to be the same thing. Alright, so this is our first example. This is just a formula that you need to know. The limit of sine x over x is equal to what? It is equal to 1. And that's just a formula that you're supposed to know. So this question may or may not be on your test. But you will have to know this formula because there will be one, which we're going to do an example, where you have to manipulate it and you end up getting this as your... Like you have to use this formula in your answer. So this is the second formula that you need to know. 1 minus cosine x over x. And it's equal to 0. If I plug 0 in for x, even if I don't even worry about the cotangent, it's going to be 0 times whatever cotangent. It says 1 over 0, which I can't do. Okay, but it should be able to give you 0 over 0. Alright, sorry. So now that we have a right problem, the tangent of 0 is 0, and I would have 0 over 0, so there's something I have to do algebraically. I can write tangent as what? Sine over cosine. So I can rewrite it as sine x over cosine x. And the trick to these, if you do have a trig limit, is more than likely if it's 0 over 0, you're going to do something to where you have sine x over x, or 1 minus cosine x over x. So you'll manipulate it like this. And then if I put x over 1, I have a fraction over a fraction. I can use what I call the ear. So the outer ear, it goes on top. So 1 times sine x is sine x over x times cosine x. Right. And we're still taking the limit as x approaches 0. Right. From here, I have a sine x and an x, and that's what I wanted to have. So we'll finish this one tomorrow. So all we have to do is look at the graph here. So what we want to look at is, this means the limit of, as x approaches 3 from which side?
Left.
The left. So we want to find x equals 3. So it's kind of blurry on this picture, but it's right there. X equals 3 is right in there somewhere. Right there. Okay. So we want to go from the left, and as we get closer to x equals 3, we get close to what value? 6. That's all there is to that. So since it doesn't say from the left or the right, then I've got to check both sides of the equation. So as I come from the left, my limit goes to -6, and as I go from the right, it goes to 3. So does this limit exist? No. The left and the right limits have to be the same, or it doesn't exist. So if I come from the left, and then I come from the right, and those places don't meet at the same point, then it doesn't exist. So if I plug 9 in here, I got 9 minus 9 on top, 0. 9 squared is 81. 81 minus 81 is 0. If you get 0 over 0, you have to do something. I can't have that. So I have to factor. So 9 minus x is on the top. How do I factor the bottom? It's a difference of squares, so it factors into what? Yeah. X plus 9 and x minus 9. Now, is this on top the same as what's on bottom of either one of these? No. But I can manipulate it to be like that. That's why I wanted to go over this one, because sometimes y'all are not super comfortable with factoring. So the signs are different with this x and this 9, right? Like this is a positive 9, this is a minus x. Well, the signs are different down here. So really on this top part, I can factor out a -1 if I wanted to. So on this top part, if I took out a -1, it would change the 9 to negative, and it would change the x to positive. I just changed the order of them. So then I would have x plus 9 and x minus 9 on the bottom. Now I could cancel it out. So the x minus 9s would cancel out. And don't forget, we're still taking the limit as x approaches 9. Alright, so and it'd be x plus 9. Yes, so the limit as x approaches 9 is equal to -1 over 18. So I don't even have to write that part. I just write equals -1 over 1/18. And this, I guess if you want to, call it
Where'd you get the
example 2. I could have just as easily wrote this step. Alright, when I pulled the -1 out, I could write it as -9 plus x over x plus 9, x minus 9. And then if I wrote it like that, sometimes you don't see, it's not exactly the same as this, but it is the same thing. So I just went ahead and flip-flopped it in that order so it would look exactly like that, so you'd see it easier. But this is what I did, and then I went to here. Does that make sense? So what I can do here, if I plug in 7 squared is 49, 49 minus 49 is 0. Plug in 7 to the bottom, 7 minus 7 is 0, so I need to factor. So the limit as x approaches 7. Alright, and I can factor that to x minus 7 and x plus 7 over x minus 7. Then the x minus 7s will cancel out. Now I'm left with the limit as x approaches 7 of x plus 7 over 1, because it canceled off the bottom, so I really don't have to write it. I could if I wanted to. So it's just 14. So there's, on the limits as x approaches negative infinity, if there's a polynomial over a polynomial, there's only 3 things that could happen. Either your highest exponent is on top, your highest exponent is on bottom, or the exponents are exactly the same. That's all there is to it. So there's 3 rules to remember when I look at this. If the highest power is on top, your limit is just whatever this is. Since it's negative infinity, that's negative infinity. That's your answer. This would be example What is it? 4? 4. Okay. So example 5. Let's go. Limit is. That's a good one. So here's my problem. So the highest exponent is 2. X squared is the highest on top and bottom. All I do is I take the coefficients, regardless of whether this is negative infinity or positive infinity. Doesn't matter if this is negative or positive infinity. If the powers are exactly the same, I just take the coefficients in front of the highest power. So since this is x squared, 4 is going to be on top. This is x squared, and the 5's in front of it, so it's going to be 4 over 5. So I've got the limit as h approaches 0. My f of x is x squared. That's equal to f of x. It would say that in the problem. That's f of x. So on my top, everywhere that there's an x in your polynomial, everywhere there's an x anywhere in any equation that you worked out, you would plug x plus h in for that. So my polynomial is x squared minus 3. This is my polynomial. It's x squared minus 3. I just put parentheses there.
Why do you plug in?
So after we plug in the x plus h bracket, I put the x squared minus 3 in brackets. I put whatever that other function is in brackets. I do that to help me to remember I got to distribute that negative out when I full it. And there's an h on the bottom. Can't forget that. So when I distribute that out. So now I just got to go through and full out the top. So the limit as h approaches 0. When I full this top out, y'all can full it out however you want to. It's going to be x squared plus 2x plus h squared. Alright, then that's that. So then I've got minus 3. And then minus, because I distribute this negative out. So minus x squared plus 3. And everything is over h. This should be 2xh. 2xh. Distribute. So I fold this out to get this right here. Because that's what x plus h squared means. It means that times that. Right, then I need to see if anything is going to cancel out. So I got plus x squared minus x squared, so that'll cancel out. I've got negative 3 plus 3, that'll cancel out.
2x plus h. Can you factor out an h?
Yes, I can. So with what I've got, since this is all I have left, right, and they both have h's, I can go ahead and factor out an h if I want to. Because if I just plug 0 in for what I have left, I would get 0 over 0. So I need to factor out an h in this top part. I need to factor out an h in this part here. So if I take one h out of 2x h, then I'm left with 2x plus h. Alright, so then those h's will cancel. And the limit is as h approaches 0. So I'll plug in 0 for h, not x. So 2x plus 0 is just what? 2x.
So 2x is the limit?
Is the derivative. Or, yeah, it is the limit in this case. But ultimately, the 2x is the derivative. Tangent line. So it'll tell you to find the slope of the tangent line of f of x at x equals negative 2. So you'll use the definition of the derivative to do that. So our definition of derivative is the limit as h approaches 0.
Is it always going to be the limit? So h approaches 0?
Yes, this is because this is the definition of derivative. So anytime you see definition of derivative, it's going to be this. It is minus. I'm just going to erase. It'll be this formula here. So now I just got to plug that in. And then I always use parentheses because it's easier for me to see what I'm plugging in. So I'm replacing every x in f of x with a parentheses. And then I've just got minus the function again. And it's all over h. So I'm going to go back in and plug in x plus h for that in place of x in this first function. So I'm doing the same thing. This one's just a little longer because it's got another x in there. But really, over here, though, I've already fulled out x plus h, so if you did it right the first time, you've already done it once. So when I go back over here to full this out again, I already know that it's x squared plus 2xh plus h squared. Then I just got to distribute this 3 out to the x and the h. So that's plus 3x plus 3h minus 4 in here, and then I got to distribute this minus sign out to everything. So it's going to be minus x squared minus 3x. Oh, yeah, sorry. Plus 3x plus 4. Is it minus? It's plus up here. This should be plus. So this one would be minus. I just skipped it. Does that make sense to everybody? I corrected that? It was plus up here in the original f of x it gave you, and I wrote it down as plus there. It should have been plus here also. So when I distribute it out, it makes it minus. Everything is all over h. So then I got to go through and see what cancels out. The x squareds cancel out, the 3x's cancel out, and the 4's cancel out. Okay, so now I just need to, sometimes when it's this long, I probably want to just rewrite it so I can see what I've got left. So I've got 2xh plus h squared plus 3h all over h, and I can factor an h out. And does everybody see if I factor that h out, the h on the bottom is going to cancel out? That's what I'm wanting to happen. So I'm going to skip writing that step if that's okay with everybody. So really I've got 2x plus 1h plus 3. So now as the limit is h approaches 0, I plug 0 in for h, and my limit is 2x plus 3. So then I'm almost done. All I've got to do is go back. It told me to find it at x equals negative 2. Right. So f prime of, if I plug in negative 2, because this is f prime, if I plug that in there, that's 2 times negative 2 plus 3, which is negative 1.